This is the Autonomous Sailboat team. As you can see, we've grown from the past years, and this is our fall 2014 critical design review. What do I do here? Thank you. Okay, so a little bit about the project this year. First of all, I'm going to have everybody a part of the crew introduce themselves and let everybody know what team they're a part of. The teams are a design team or the electronics/code team. So let everybody kind of do that. Would you like to start?
Okay. I'm Jade Sorensen, I'm part of the design team.
I'm John Nagel, and I'm with the electronics and coding team.
I'm Travis Niedenfear, and I'm with the design.
I'm David Wooten, I'm with the design team.
I'm Luke Ellis, I'm with the design team.
I'm Neil Crooks, I'm with the design team.
I'm Elizabeth Sexton, and I am team lead design.
I'm Jack Johnson, and I'm part of the design team.
I'm Robert Barris, and I'm working with Code and Electronics.
I'm Ryan Wade, I'm the electronics code team lead.
Jackson Broad's design team. I'm Grant Stanton, and I am on the design team.
So that's everybody a part of our crew this year, -1. We also have Parker, who's not able to make it tonight. So basically our mission statement's below. The goal of this project is to create a sailboat capable of performing all of the required objectives in the 2015 Sailboat competition in Newfoundland, Canada. So woohoo. As a secondary objective, the boat should be capable of completing these tasks as quickly and efficiently as possible. So a little bit of our overview as well for the goals for the year. Obviously, our main goal is to travel to a competition this year at 2015 in Newfoundland and kick butt. So also to gain sponsorship because it's going to be quite expensive to get there and back. Also building and testing the wing sail, improving and testing sailing logic, researching and designing a new boat if we have time. So now I will switch over to Luke to talk a little bit more about the competition.
Okay, so the competition, as we said, is in St. John's, Newfoundland this year. Is hosted by the Royal Yacht Club of Newfoundland and Memorial University, located in Newfoundland. The competition consists of 5 parts. The first one is the fleet race. This is the only portion of the competition where it's mainly manual controls because we are autonomous. And that's just the entire fleet, all the boats entered in the competition, race around designated buoys, things like that, and it's based off time. So first one with the lowest time wins. Station keeping, this is a 40 meter by 40 meter box set up with the buoys, and you sail your boat into the box autonomously, and the max amount of time given is 5 minutes, and your score is based on how long you can stay in that box with a max of 5 minutes. Navigation, this is autonomous. It's just a course set up with buoys, and you just enter your code, and it runs around the course they have set up. Presentation, that's based off aesthetics, innovation, just how you designed your boat, how well it's put together. And then a long distance race is a 10-kilometer endurance race with different checkpoints, and the boat with the lowest time wins that as well. The different classes, there's only 3. They're all sailbot, but there's a 1 meter sailbot, 2 meter sailbot, and then open is manual controlled sailboat.
Okay, this is just a little brief overview on the whole design. As you can see, it's made out of carbon fiber and also has plastic boxes to protect the electrical components from water damage. The total dimensions is within the competition parameters of 2 meters by just a little bit, as you can see, with a 1.99 for hull length and 1.98 for hull depth. Also has a 1.37 meter keel, a 3 meter mast, and a 3 meter wing sail. Okay, on to design.
All right, so as I said, I am the design team lead, and I am here to introduce our wing sail to you. So this is a rendering of our wing sail. We model it on a NACA 0012 because this airfoil actually provides a maximum amount of lift at our ideal sailing conditions. So it is a symmetric airfoil, so it does provide lift on both tacks or both sides of the wind. So what's really cool about our wing sail is that it's more efficient, so it does sail faster with less wind, and it is on the cutting edge of sailing technology. all of the world-class racing boats are using wing sails, the America's boat specifically, which the United States won in the last round using a lovely wing sail. And I will hand it off to Neil to play a little bit more.
All right, so on the picture that we included is kind of what we're trying to imitate. Yeah, so that picture is what we're trying to imitate. Kind of the skin of the wing sail will be mylar, and the ribs will be made out of polycarbonate, and the spars will be carbon fiber. We're going to put those all together with just screws and glue, and then the edge support is just balsa wood. So we're going to add Jackson will talk about the building process.
Thanks, Neil. So we're going to use a CNC machine to cut the polycarb ribs out, and we're going to connect those with, like you said, the carbonate spar, and we're going to wrap those with mylar, and then we're going to finally weld the aluminum mass into a gear cog so it can be able to rotate using the servo drives. And here is a lovely picture explaining what I just said, and to pass it off to wing sail analysis.
Okay. So wing sail analysis is split into two parts. The first part is going to be CFD. This will allow us to find the external loads, such as the pressures on the both surfaces of the wing, and pressures, moments, stuff like that. So we started the CFD using a program called Star CCM last semester. We got some results. The two pictures you see there actually are some pretty pictures showing that. The top one you can actually see that is basically what you're seeing is induced drag. As the air comes around the zone of high pressure over the low pressure, you actually get that tip vortex. So in theory, we would like to reduce that vortex to reduce our induced drag, but we'll get there. The bottom picture you can see is part of, you can actually see the air flowing over the cross section of the wing, of the actual wing sail itself. And if you notice, what you can see is the air is actually flowing as a kind of a laminar flow over the front section of the wing, but then separates as it goes over the control surface. So we're going to try this semester. We're going to try to play with that spacing between the fore and the aft wing element to try to get that flow separation down to as small as possible. That will help us actually make use of the aft element and reduce drag and just help with everything. But we do have a few CFD questions. We're not experts in it, so we are trying to figure out how we're going to handle leading and trailing edges in the CFD code. How can we help with help the flow interaction between the main and the aft elements, which is what I was talking about with the flow separation, and then how do we handle angle of attack to get angle of attack in the CFD code itself, so that we can do lift, so we can get lift on a symmetric airfoil. So once we have those external loads, we can go find all the internal loads using finite element analysis. So if anybody's familiar with ANSYS, this is probably where we're going to start. So here we're going to do three things. We're going to do a static analysis. This is just basically what the code's doing is it's basically solving a truss with 100,000 elements. So that's all it's doing. So that will give us just kind of internal load stresses on the actual internal components, the ribs, the spars, the mast itself. But we're also going to look at a dynamic mode, or dynamic mode. So because we have a very high aspect ratio wing, there's a chance that the top could flutter a lot. So basically it will vibrate in the wind, which could be very catastrophic. So we have to be able to try to minimize those. But our objectives for the ANSYS is to optimize the rib shape and placement. How many ribs do we need? What shape of the ribs? Can we reduce the area inside of the ribs? We're going to check for unwanted dynamic modes. That's the flutter. And then make sure we're not going to fail under constant loading. That would be a static analysis. Now, there are some questions. ANSYS is extremely complicated. So we want to make sure we're going to use the right elements. So a structure element versus with 6 degrees of freedom, or do we want to use something that's a shear panel, which only has 3 degrees of freedom, or the membranes? It's very complicated. And then handling contact surfaces is another part that we need to look into. So how are we modeling essentially the glue between the mylar and the ribs, or the epoxy that's going to hold the mass to the ribs as well. So all questions we have to solve, which is pertaining to the analysis, which has to get done very quick early on in the semester.
All right. And I'm going to talk a little bit about electronics and code work with Ryan this semester. All right. Okay, so for electronics, currently, picture this being the bow, the front of the boat, and this being the stern, the aft of the boat. We have an electronics box for the rudder servo, the main servo, the GPS, and the Ardu pilot. we kind of want to condense this to make it a little easier to get at each component. Additionally, there's a hole in the waterproof box for the GPS. So we want to combine the battery, GPS, transceiver, power regulator all in one waterproof box in the front. And what that's going to allow us to do is get in and out of that box very quick, because currently we need to go and we need to take down all the rigging just to get at our battery to power up. So that's one aspect we're going to work on for improving the boat. Additionally, the wing sail servos, we're working with the design team to try to figure out, do we have a configuration that allows enough torque for us to control this? And then furthermore, the wind sensor. Currently, if you have your main sail right here, I apologize for not having pictures, our wind sensor is aft of that. So we're getting all that downwash and all that turbulence from the wing sail. So we're evaluating, is it really worth moving somewhere else? How much do we have to gain from it? So all things considered this semester. Code-wise, right now the code is kind of scattered throughout the RDuplane code, and we want to be able to develop that so we have a better understanding of where everything is and how to implement it. And Ryan will get into that a little more.
So we are rewriting our main control loop. Currently, our sailboat only has a direct path mode. So when you give it the waypoints, it goes from point A to point B, and even if that's wind, it still tries to do it. Obviously, that doesn't work in sailing. So we're rewriting it to include tacking, some other sailing techniques, and overall improve that with a state machine of sorts. So we have a simulator that we wrote last year to do testing of that logic, so we can test that logic outside of the sailboat so we don't have to go to a lake. We've also been thinking of several different testing methods this year, such as putting the boat on a push cart of sorts so that we can actually give it some information and run the code on the unit and get the feedback into, what is it called, map?
Mission planner.
Mission planner, yeah. Let's see here. I think that about covers that. So also, as part of the code electronics team, we've been working a little bit with controls in collaboration with the design team. So here is a quick 40-second video on our planned method of controls. So we have a main gear that will be welded to the main mast with a servo that spins it. The wing sail will be divided into two components. The trailing edge, the trailing wing will be independently controlled. And what this allows for is we can actually have 4 servos to provide torque. So in the calculations that we'll be getting from the design team on how much force we are going to have, we'll be figuring out which servos we need and other calculations. Also, by dividing the wing sail in 2, it's a lot easier to transport at 3 meters long. It gets, it can't fit in a regular van, and so our hope is that we can put it in a van to save costs on renting for our budget. And I think that about covers it. So next, we'll pass it off to Travis.
I'm Travis, and I'll be talking a little bit about what we've been doing lately with the boat as far as getting things ready. Recently, we've been working on a mock-up of the wing sail that we're going to be building. We're making it out of cardboard and wood. And this is a really cost-effective way for us to test our different theories and concepts that we want to actually use in the actual wing sail without spending a whole lot of money on expensive materials. Cardboard is really easy to come across, so is wood. So this is going to allow us to figure out the kinematics of the sail and just make sure that everything's going to work before we actually build it for real. It's also going to provide us with something that we can actually hold in our hands and show to other people when we're talking about our boat. Even if we don't have the actual wing sail itself done, and we want to show the boat off for different presentations or recruiting efforts, we will be able to use this mock-up of our full-size mock-up of our wing sail to help draw people in and further promote the group. So I'm going to pass it off to John. Oh, Sarah.
Oh, so general items. So we will pass it off to John and he'll talk a little bit more about testing.
Sailbot we have tested twice so far this year. Unfortunately, both times were not met with ideal results. The first time we found out we had a broken fuse in our controller, which we then fixed. And then the second time we went testing, which was 2 weeks ago, it was pretty cold and windy, and we set the sail and boat up and everything, and it bent our mast. So that's kind of where we are right now. And both times we went out to Ada Hayden. But then the purpose of our testing, we want to test the autonomous code, make sure it works. It's not fun writing a code completely and then finding out it doesn't work. So hopefully do it step by step. And then test out the new modifications that we make for the boat, which will hopefully this year include the wing sail. And we found out 2 weeks ago that winds above 20 miles per hour is a little too strong for the boat. And another thing we have done is we made a checklist. So, because we have lots of little bits and small pieces that we need to bring along. And so we'll remember everything so we don't have to get out there, drive back to house, grab something, go out there again. Oh, still forgot something. Makes things smoother. And setting up the boat is a team effort, and we've learned how to do that quite well so far. Next is our budget.
So this is a slide a little bit about our budget. Hopefully it makes Matt smile because it's not, ungodly high. We've made a lot of cuts, honestly, to our budget that we originally had. One of the cuts being our mast. So we're deciding to go full speed ahead with just the wing sail. So that would only have our budget include one mast, or even not as expensive as that, something like a square rod of some sort or anything like that. So we're not quite sure where we're going with that, but that's been cut down so we don't have to buy 2 masts now for $600. Electronics budget is going to be a lot with buying waterproof boxes for moving things around, buying new wires and such like that. So that's our budget there. And then the sail modifications, this is all of our budget that we need for the wing sail itself. Building materials such as mylar, if we need some balsa wood, such. Also, there will be 4 servos in the back section or the trailing edge to control that. And those 4 servos are a little bit expensive, but it's going to be about $200 for the 4. They're about $50 a piece. And I have more information on that if anybody has questions. So another big thing we cut out with going full force forward with the wing sail, we don't have to rent a car from the university anymore. We're able to load it up into one of our vehicles. We don't have to pay $50 every time we go out and test. So it's a lot easier for us then. Competition travel is going to be very expensive this year because we are going to Canada. We're looking for a lot of sponsorships this year and working towards that, which we'll talk about in a little bit. But that's just kind of average numbers. It might be a little bit more expensive, a little bit less expensive, and that's all only for 4 people. So that's our budget. So I assume Matt will have questions later, but we'll keep going. So next we'll have a little bit about sponsorship.
So as Sarah mentioned, sponsors are going to be very important for supporting the team and allowing us to go to competition this year at the International Robotics Sailing Regatta. And the money for the sponsors will be used to help cover travel expenses and other competition costs moving forward. So currently we're publicizing our interest in sponsorship with the website, and we've also made up some flyers to give out to potential companies. The flyers have information generally about how we can help expose the company name, and then different levels of sponsorship that we're offering to the companies. So as it's shown on the slide, we're looking to display the sponsors with Team Apparel website and social media accounts. And our hope is that we'll be able to attract companies that see the importance of programs like M2I and Sailbot as an investment in the future of the engineering industry. So.
How's it going? I'll be talking about our social media. And this is a picture of our website, the front page. Our kind of goals for this semester are to be like more personal and to let everyone know what we're doing. So there's really openness. We post what we do, at meetings and what we covered and what we've been working on, so everyone can see what we've been doing and what progress we've made. And there's a weird sound happening, but we're just going to get through it. This semester, we've also been working on our members getting bios. I hope to get coding done where there can be photos and it'll look a lot more clean. It scrolls down a lot for all the members and like a little bit about them and how long they've been in Sailboat and such. So we're working on that. Gives people who are looking at the Sailboat a little bit about who we are. I think it's good. Our sponsorship page, it's a little bit about, if companies want to sponsor us and a little information on us and how they can get in contact with us. Because we'd always love help and monetariness. Our Facebook is directly linked to our website, so anything that gets posted on our website gets posted on our Facebook. Again, it's just open. We love to have people care about what we do, so we're trying to get all the information we possibly can out. And we're trying to update as often as we can with photos and posts and such. Just, keep people up to date. So,
really can't see me. It's fine. So as a new member, there's a few of us this semester who's on the team now. I just started at the beginning of the semester, and I'd say that the team was very welcoming and helpful, getting everything ready for me as far as any help I needed with the design team and all the other computer programs that I needed. When I went to my first meeting, or when a bunch of us came to our first meeting, it was really open for discussion, and everyone kind of asked for everyone's ideas. And meeting every Sunday was also very nice and easy for everyone. Testing, when we went to test, it was very cold, and they first threw us new members out there and said, okay, you guys are going to have to put it together and then try and figure it out yourself. Everyone still enjoyed being there, which was really nice because we were all working, it was freezing, and we were all working towards so we could test. And so everyone being positive and being there was just nice to have. Also, everyone's been very available and willing to help with the group, I'd say, and really agreeing with each other. And we're all really interested in the project and want to see it succeed, which is also a good thing for a group to move forward instead of always having to go backwards and things like that. And then I think Sarah's going to close it for us.
So just to reiterate some closing thoughts here, sorry, that's really distracting. One of the main things, obviously, is going to be constructing the wing sail and testing it. That's our huge goal for this year, to get that ready before competition. Also testing and improving the code and the logic, making sure that we have the best code that we can have. Obtaining funding for travel so we can actually get there, and then also competing in the 2015 Sailboat competition. So now I'll open up the floor to anybody who has any questions or concerns or comments.